Hello, welcome to another lesson in Algebra 1. Today we are covering Module 1, Lesson 7. All right, so our warm-up, a picture to represent the mathematical expression of x plus 2 times y plus 1 is shown below. And what this is saying is take the length of x plus 2 and times it by the length of y plus 1. And inside each of those lengths, we have a variable term that we don't know exactly how long it is. So we're finding really the area of this length times this length. So down here we have a picture that represents the area of those. So our horizontal length is x plus 2. Our vertical length is y plus 1, and they form a rectangle. And the area of this rectangle is going to be, well, this piece in the top left is x times y. Remember, to find the area of a rectangle, we do length and width. The top right would be 2 times y, this y part and that 2 part, okay? The bottom left would be 1 by x, so that's just x. And then the bottom right would be 1 by 2, which is 2. So we have 4 areas to represent the big area. So our final answer for this expression is going to be, let's see, xy plus 2y plus x plus 2. Now, later on, we're going to see why I should really write it the opposite way. So we should really put plus x plus 2y plus 2. And we'll learn about that when we talk about the degree of a polynomial. All right. Second part, write an equivalent expression by applying the distributive property. So this is still review from last module. So let's try to do the distributive property. So I'm going to take the x plus 2 and I'm going to distribute it to both things in the second parentheses. So this will turn into, let's see, well, the inside only has one number, so let's put the y part first, and then times x plus 2. And then we have plus 1 times x plus 2. So I took the x plus 2, I times it by y, I wrote that there. I put the y first, but you can put it second if you want it. And I took the x plus 2 and I times it by 1, and I wrote it in the second spot. And once again, you could put the 1 in the back, or you could just think about, wow, if I times something by 1, it doesn't change, okay? All right, so we'll go ahead and do the distributive property again. So we do y times x, which is xy, alphabetical order. Y times 2, which is 2y. 1 times x, which is just x, and then 1 times 2, which is 2. And once again, we really should write those in the other order, but we don't really mind about it right now. Okay, so these two expressions are equivalent. All right, label the picture below to represent x plus 2y and y plus 2. So let's see. Y plus 2, I'm going to probably have to go this way. And this one's going to be x plus 2y's. So this is my x, that's a different length. This is length y, and this is length y. Now, as you go forward, it doesn't really matter how long you draw them, but we're trying to say that, hey, look, this is really a y, and that's a y. So in there is going to be a little square, okay? And we'll see how that works out. So let's find the area here. We're going to do x times y for the top left. Y times y, well, that's y squared, okay? Y times y is y squared. 2 times x is 2x. 2 times y is 2y, and 2 times y is 2y. Now we have to combine our like terms. Okay? So we have xy, and then we have y squared twice in here, so that's 2 of them, so 2y squared. And then we have a 2x, and then we have 2y twice in here, so 2y plus 2y will give us 4y for that area. All right. Now we're asked to do the same thing as above, which is to write an equivalent expression using the distributive property. So we have x plus 2y times y plus 2. So I'm going to do the distributive property, and this time I'm going to do it in reverse. So I'm going to take the y plus 2 and I'm going to distribute it to both of those. All right, so I'm going to say y plus 2 times x and 2y times y plus 2. So y plus 2 times 2y. All right, now I'll distribute the outside parts. So the x will distribute to the y to make xy. The x will distribute to the 2 to make 2x. The 2y with the plus, positive 2y, distributes to here to make plus 2y squared. And then the 2y distributes to the positive 2 to make plus 4y. And then we could just reorder it to make it look just like above. So the xy would come first. The 2y squared would be second. That uses that one and that one. And then the 2x would come, and then the 4y would come. All right, so two different methods to do the problem. The tabular method here, okay, the area model, and then just using the distributive property here, okay? All right, Susie draws a picture to represent the sum of 3 plus 4. Ben looks at the picture from the opposite side of the table and says, hey, buddy, you didn't draw 3 plus 4, you drew 4 plus 3. Explain why Ben might interpret the picture that way. So what he's looking at it is from this direction. So he's saying, oh, that's 4 and then 3, not 3 and then 4. So both people are correct. And he's saying that really these two should be equal. So Ben looks at it this way. Explain why Ben might interpret the picture this way. He looks at it from the opposite side. And sees 4 plus 3 instead of 3 plus 4. But remember, these are equivalent anyways. Okay? 3 plus 4 is 7, 4 plus 3 is 7. In both cases, we see a length 7. All right, let's flip it over and check out the second page. All right, so Susie adds more to her picture and says, hey, look now, Ben, this picture is 3 plus 4 plus 2. So she says, look, it's the 3 plus 4 we had before, so that's why I put it in parentheses, and then we have plus 2 more, so that's this 2. Now, how might Ben interpret this picture differently? Explain your reasoning. So I'm going to say, well, maybe Ben's looking at it still kind of weirdly here. And he's going to say, well, no. The first two numbers are the 2 and the 4. So we should be adding the 2 and the 4 together first, and then it's plus 3, okay? Or the 4 and the 2 together first, and then it's plus 3. Like this. Okay, so he's saying, oh, look, it's this 4 plus this 2 first, and then we're going to add on the extra 3 because he's reading it over there. So, all right, so why would he interpret it this way? Well, he's reading it from the opposite direction, okay? So he's going to think that you have to put the 2 and 4 together first, okay? So how might Ben interpret this picture? He might interpret like this because he's reading from the weird direction. So he's seeing the 4 plus 2 as the first thing, and then the 3 is the extra thing being added on. All right, so now the question is, does it matter in what order we add or multiply numbers? Okay. For example, is 3 plus 4 the same as 4 plus 3? Would it make a difference if one of the numbers were negative? Well, we already saw in the first example that 3 plus 4 is the same as 4 plus 3. They're both 7. If we were to make one of them negative, let's just check and make sure that it still works. So 4 plus negative 3, both of those have a result of positive 1. And if we flipped and make the 4s negative, they both have a result of negative 1, so it'd still work. So it doesn't seem to matter in what order we add. Now, does it make a difference for multiplying? Let's check that out. Is 3 times 4 the same as 4 times 3? Question mark. And this would be yes, they both make 12, right? All right, so what if we made one of them negative? Is negative 3 times 4 the same as 4 times negative 3? And that answer would still be, yeah, that still works. It's negative 12. All right, so in math, it doesn't matter in what order we add or multiply. We get the same thing. And they give this a name. This is called the commutative property of addition or the commutative property of multiplication. Okay? So we just can call it the commutative property, and we'll put a little dot by it for multiplication, so something like this. Commutative property for multiply, or the commutative property for addition. Okay? And then we also learned already the distributive property, at that last time, and then we have the associative property for multiplication and addition. The associative property comes from what we were doing up here in number 2. So you can, as long as you keep the numbers in order, you can move the parentheses around adding or multiplying and still get the same value. So here, the parentheses would say do it first, so 7, and then plus 2 is 9. And here, the parentheses would say do this part first, which would be 6, and then plus 3 more still gives you 9. So the same works for multiplication. As long as you have 3 things multiplied together, you can put parentheses anywhere along those 3 things you feel like. Okay? All right, so fill in the sentence circles to show a flow diagram that illustrates 3 plus 4 plus 2 equals the same as 2 plus 4 plus 3. Okay, so we want to show what's going on. So this is what we started with, 3 plus 4 plus 2, and that was right here. Okay, so we're going to show all the things we could do. So think about this. This is 3 numbers, and they're all combined with addition, and we have some parentheses around it. So we could move the parentheses, 3 plus 4, these parentheses here, and switch them to the 4 plus 2. What property moves parentheses around 3 things? Well, that's the associative property for, in this case, addition. So we'll put associative for addition. Okay. All right, now that moved it that way, but that did not get us what we wanted. We wanted it to be 2 plus parentheses 4 plus 3. So let's think of some other things we could have done with this. So how did we go down this arrow? What changed? So what changed here was it took the 2, the plus 2, and moved it to the front and made it plus 2. Nothing else changed. The 3 plus 4 and the 2 switched places. And they switched places around this addition. So 3 plus 4 went where the 2 was, and 2 went where the 3 plus 4 was. So this didn't move parentheses. What it did was switch 2 values around the plus. So this is commutative property of addition. Okay. That didn't get us to what we wanted yet, because that's still not the answer. It's pretty close. So let's follow another path here. Okay, so the next path we could do is say, okay, well, we did associative property with addition here. We did commutative property with addition. Let's see what this next one is. This one's also a commutative with addition, but a little bit different. The plus 2 stayed right where it was, so the only thing that changed was the 3 and 4 changed order inside the parentheses. So it went from 3 plus 4 to 4 plus 3. If you change the order in which you add, that's commutative property. If you move the parentheses to change who gets added first, that's the associative property. So a commutative property does not move parentheses. All right, so in both of these cases, though, we want to move the parentheses around. We've got things kind of lined up. We want to get them into the right spot. So let's take a look at this one. 2 plus 3 plus 4, I wanted to rearrange it so I get 4 plus 3. So it was 3 plus 4. What rearranges it? This is going to be, once again, my commutative property. Okay, commutative for addition, we'll switch it around. And then I end up with what I want. So that's one way to prove that these 2 expressions are equal. Another way is I've already got to here, okay, and then I can do the commutative property again. So move the 2 to the front and the 4 plus 3 to the back. So that's commutative for addition. So what we didn't want to do was associative property. It didn't help us. Okay, so now here are 2 ways to prove that the blue one and the green one are equivalent. One way we could do these steps and write these reasons. The other way we could do these steps and write these reasons. Okay, so what is special about the expression shown in the all the expressions shown in the flow diagram? About each expression shown in the flow diagram. So these expressions are all equivalent. What does equivalent mean? Well, equivalent means they're equal. Okay, so no matter what way I do this, they're all going to work out to the same answer. All of these answers are going to be 9. We're just moving the symbols around in the orders that we do, as long as we follow these properties: distributive, commutative, and associative property. Okay. All right, so fill in the blanks for the reasons for each step of the proof that shows that those 2 are equivalent. So which way did I follow? I went with this way, the downward way. So I changed 3 plus 4 in parentheses plus 2 into 4 plus 3 plus 2. And this was the commutative property of addition. And you could just say 4 plus. And then we did it again. We placed this and this around this plus. So this was going to be the commutative property for addition again. Okay, so in both cases, we switched around a add sign, the things on both sides of the add. So the first one, we switched the 3 and 4 around the plus there. And then in the second one, we switched the 4 plus 3 in parentheses and the 2 around the plus. When you switch around a plus, two things around a plus, then it changes the order. You're doing the commutative property. So is there another way to show this proof? If so, show it below. And yeah, there is. We could have done that way, the top way. Okay, we use the bottom way. We're going to use the top way also. So our proof would look something like this. 3 plus 4 in parentheses plus 2 is going to equal to the same as, we'll get that middle one, 2 plus 3 plus 4 in parentheses. Okay, we'll get a reason for that in a second. And then that turned into our final answer, which was 2 plus 4 plus 3 in parentheses. Now, once again, what did we do in the first step? So in the first step, we took 3 plus 4 and 2, and we switched them around the adding sign. So when we switch around the adding sign, that's commutative property for addition. And then in the second step, we took the 3 and 4 and we rearranged them around the adding sign. So once again, this is commutative property for addition. Okay, on our third page, we have number 6, which is draw a flow diagram and use it to prove that x times y in parentheses times z is the same as in parentheses zy equal to x for all real numbers x, y, and z. So what we have to do is start with this thing and then follow our properties. Our properties are the commutative property, the associative property, because it's all about multiplying, and the distributive property. And if we can make those properties make the left side turn into the right side. Okay. All right, so let's start with it. We have x, y, and then times z. Now, I'm going to start with trying to just get the letters in the right order. So I would like the z to be in the front. So I am going to switch it around like this. I'm going to move the z to the front because I'm allowed to do that by one of my 3 properties. And what did I switch around? Well, I changed the z spot with the parentheses xy spot. And I was multiplying between them even though I didn't see it. So I just switched 2 things. That is the commutative property. For multiplication. Okay. All right, now I would really like to go ahead and get that y to be second. Okay. Well, that's no problem. I have z, and then I'm just going to switch the y and x around because I'm allowed to change the order in which I multiply. These were x times y. I can change it to y times x. Okay. What property allows me to change the order that I multiply? Once again, this is the commutative property. So in the first step, we changed the order of z and x times y. Flipped them around. Z went in the front, the x and the y went to the back. And the second step, inside the parentheses, we changed the order of x and y. All right, now lastly, what I want is to get the y and the z and the y to be in the parentheses together instead of the x. And there is a property that allows us to change the parentheses around. Okay. So I can do this step, parentheses zy and then times x, which is what we want. What property allows us to move the parentheses when the values all stay in the same order? So xyz, nothing changed order except for the parentheses moved around. And the property that allows us to do this is the associative property for multiplication. Okay, so associative property lets us move the parentheses. And you might say, well, but Mr. Elliott, you moved these parentheses. And I say, no, I didn't. What I moved was this term part and this part of it. So I took the xy as one thing and the z as one thing and moved them. That didn't move the parentheses. It moved the z in front of the parentheses instead of behind the parentheses. Okay. Here, I took the parentheses that were around y and x, and instead I moved them around the z and y. That's moving the parentheses. The letters stayed in the same order, the parentheses moved. Notice up here, it was XYZ and then ZXY. So the letters were in different order. That's going to be commutative property. Okay. Number 7, we want to do the flow diagram to prove that W times W plus 5 equals 5W plus W squared. All right, so W times W plus 5. Well, I have 2 branches coming off of my flow diagram. I have this one. Let's see what happened there. That looks like the parentheses went away, and the only thing that can take parentheses away is the distributive property. So that's going to be a D in there for distributive property. All right, now going the opposite way down here, well, the parentheses didn't go away. The W is still on the outside, but inside it went from W plus 5 to 5 plus W. So the order of the adding changed. Order of adding is commutative property with addition. Okay. And then we're doing a couple other things. So in this line, we have W squared and then plus W times 5. So what changed here? Well, the W squared went from the front of the plus to the back of the plus. So W plus 5 moved in front and W squared moved behind. Okay, so we're changing order around the plus. So this is, once again, the commutative property for addition. The plus is what we're changing the order around. Okay. All right, let's go down to this bottom branch. We had W and W plus 5 plus W, and then the parentheses went away. And we get W times 5 and W squared. Well, the only thing that makes parentheses go away is the distributive property. So this gets a D. W times 5 is W times 5, and W times W makes W squared. So this W got distributed to those 2 parts. All right. Now, up here, it said a commutative property with multiplication happened. The only place in this piece that has multiply is right here. So the commutative property is the order changing one. So we're going to have W squared plus 5W. I moved the 5 and W into different spots. Okay, I'm going to go ahead and finish up this branch. So somehow we go from that to that. Well, what changed? The 5W went to the front of the plus and the W squared went to the back of the plus. So that is the commutative property for addition. Okay. And then let's move down to this circle here in the middle. So we went from W times 5 plus W squared to 5W plus W squared. So once again, order changed. The 5 went to the front, the W went to the back. So that's the commutative property, but this time we're changing around a time, so this is commutative property for multiply. They did X for multiply, so I'll do the same on this problem. Okay. And then lastly, our last little circle here, we have W times 5 plus W squared. And once again, we want to change this W times 5 into 5 times W. So this is changing around a multiply symbol. So commutative property for multiply. W times 5, change the order to 5 times W. Now, a big question here. What is special about every mathematical expression in this diagram? And this should be getting to be ingrained in you here. All of the expressions are equivalent. Remember, equivalent, one more time, means equal. Okay, so the associative property, the commutative property, the distributive property, they do not change what the expression works out to if we pick numbers and work it out. All they do is change the order that we write the expression. Okay, so for problem number 8, we want to complete the flow diagram below with abbreviations for the reasons for each statement. So we have 1, 2, 3, 4, 5, 6, 7, hopefully equivalent statements. Okay, if we follow the properties, commutative, associative, and distributive, if needed, then all these statements should be equivalent to each other, which means they should all be equal statements. So if we picked a value for X and Y and plugged it into all these statements, we would find out the same number when we simplified it. Oh, and for A. All right, so let's follow a branch. Let's start with going down. We'll do these branches. Okay, we have X plus 4 in parentheses, and then that changed to 4 plus X, still inside the parentheses. So the parentheses didn't move. What changed was the order of the X and the 4. So this is the commutative property for addition. we had an addition sign in between, and we switched the order of the x and the 4, the order we added the two things. Okay. Second step here. Let's see what happened. We have 4 plus x plus 5 times a whole bunch of stuff, and now we have 4 plus x plus 5 times a whole bunch of stuff. But the difference is the parentheses that were around the 4 plus x moved from here to around the x and the 5 times a bunch of stuff. Okay? So what property moves parentheses around? Nothing else changed. Notice if we read down the line, we have 4x, 5a, 2x, y. It's all the same order. All we did was move the parentheses around it. Well, the parentheses mover is the associative property, and we moved them around adding, so that's the associative property for addition. Okay? All right, and then in our last statement, oh goodness, what happened here? Well, order changed. So the 4 was in the front of all this stuff with addition in between. And now the 4 is in the back of all this stuff with addition in between. So changing the order is always going to be the commutative property. That's our order changer. And we changed around addition sign. All right, on the top. Okay, we already have one step done for us. We did commutative property with addition. And the commutative property with addition was this addition. And we changed the order of these two parts. That was our first step. Okay, so x plus 4 moved to the back, and 5 times all that stuff moved to the front of that plus that's in between. Okay, all right, now let's follow this top branch. So how do we change this one in the middle here to this top one? All right, well, let's see what changed here. X plus 4 still on the end. 5 times parentheses a, that's still in the front. So what changed was this 2 in parentheses xy, and then the y in parentheses 2x. Well, you might be tempted to say associative property here because it looks like parentheses are moving. But think about it for a second. This says 2xy and this says y2x. So it was more than parentheses that moved because the order of the letters in the numbers changed. What changes the order of letters and numbers? Well, that's the commutative property. And this was for multiply. So let me show you what happened. The multiply that was between the 2x and the y, okay, was what we're going to change the order around. So there's a multiply right in here. So 2x and y flipped to y and 2x. We changed its order. It's a commutative property for multiplication. All right, and then we did something else to this middle one here to get the guy over there. Let's see what we did. It looks like, once again, we have 2xy and we have 2xy, but the parentheses in the first one were around the 2x and the parentheses in the second one were around the xy. So the order of the 2x and y did not change, so that's not the commutative property, but the parentheses did change. So what moves parentheses is the associative property. So this is associative property for multiplication. So on number 9 here, we want to show that this expression is equivalent to this expression. So as long as we use our 3 properties, commutative, associative, distributive, we never change the equivalence of expressions. All right, so in our first step, the only thing that changed was inside the big parentheses. So inside the big parentheses, the letters still went A, B, C with adding, but in the first set, they were parentheses around A and B, and in the second set, there's parentheses around B and C. So that is our associative property. Okay, and then we're supposed to do the associative property again. So to move here, what they want is to set it up as this, A plus parentheses, and then inside of here, parentheses B plus C plus D and parentheses. Okay, so let me write that underneath a little clearer. So A plus parentheses, and then parentheses again, B plus C with parentheses, and then D with parentheses. Okay, all right, so what moved here? Well, the A, B, C, D are still in the same order, so that didn't matter. Inside here, there was this big parentheses, okay, that combined the A and the B plus C first. And instead, we moved those parentheses in green to here. So now we're going to combine the B plus C and the D first. So it was 3 things being added up. It was an A, a B plus C, and a D. It's still an A, B plus C, and a D. But instead of adding the A and the B plus C first, we're going to add the B plus C and the D first. Okay? And then they use associative property one more time to rearrange these two parentheses in here. So B plus C plus D is still B plus C plus D, but we move the parentheses from around the B and C to around the C and the D. Okay? So this is our associative property one last time. So these three statements are all the same. When you look at these three statements, notice the A plus B plus C plus D didn't change its order in any of these. We just put the parentheses wherever we felt like it. Okay? All right, so for number 10, we tried that with numbers, okay, and we worked them out to try to show that it doesn't really matter. If you're adding four numbers, you can put parentheses into any place you feel like, and you're still going to get the same number. So if we just add these numbers up, we get 10. Okay. If we add parentheses around the first three of them, then that's 6 first plus 4 for 10, still works. We would put an extra set of parentheses inside the parentheses we had. We add those two numbers up first to get 5. We add one more on to get 6, and then 4 more to get 10, so it's still 10. Okay, here, same kind of thing. We could put the parentheses around 3 plus 4, and then around the 2 and the 3 plus 4. We're still going to get 10. 7 plus 2 plus 1. Here we're going to do 3 plus 7, still going to be 10. 2 plus 3 is 5, plus 4 more is 9, plus 1 more is 10. So if it's all adding or all multiplying, we can stick parentheses in the problem anywhere we feel like it. And that's what it's trying to say. So based on your results from 10, what would you say about the placement of parentheses around the sum of numeric algebraic values? They do not change the final answer. And this can be really useful for us in some cases to allow us to add or take away parentheses as we feel like. So for instance, in the future, we just use the associative property to realign up parentheses however we feel like it. So notice this is still x plus 2 plus 2. This is still x plus 2 plus 2. And we decided to say, just drop those parentheses there on the left side, and we'll add two new sets of parentheses to help us. Now this would help us because we could combine the like terms in the order we felt like, 2x plus 4 now. All right? So we've been talking about algebraic expressions for a while and how they're equivalent, but we should really name it. So an algebraic expression is either a numerical symbol or a variable symbol. So either a number by itself or a letter by itself. Okay? And the result of placing previously generated algebraic expressions into two of the blanks of one of the four operators. So we can say it's 2 plus x, that's this one. Or we could say 2 minus x if we felt like it. Or 2 times x if we felt like it. Or 2 divided by x if we felt like it. All those are going to be algebraic expressions. Okay? And then we can combine this algebraic expression with this one if we want it. So we could do 2x plus 2 minus x. Okay? Or 2 times x minus x. Anything we felt like. So two algebraic expressions are equivalent if we can convert one expression into the other by repeatedly doing the commutative property, the associative property, or the distributive property. And the properties with rational exponents to components of the first expression. Okay? So write a mathematical proof of the algebraic equivalence of PQR in parentheses, with the parentheses around the P and Q, to QRP with the parentheses around the Q and the R. Okay? All right, so our proof will look something like this. P, Q, R. And then let's go ahead and try to get them in the right order. So I would like the Q and R to be together. So I'm going to move the parentheses, and I think that's the easiest way. What property moves parentheses? Well, this is our associative property. And this is for multiplication. All right. Now I need the P to be in the back. I can do that. I'll just take the P. I'll move it behind the Q and the R. Okay, so that rearranges around this multiply, and what property rearranges around a multiply is the commutative property for multiplication. And now I have equivalent statements. Now the nice thing about 12 is there's a couple different ways to do it, just like for all the other ones. When we were looking back through the flow diagrams, we had many ways to get to the same expression. So for this flow diagram, we could take it and go from here and follow this way, or we could go this way, or we could go this way. So 3 different routes. So lots of different answers in our algebraic proofs. All right, I'll see you in class next time.